Hello one more time. We're still working on balancing equations, which if you remember is all about the law of conservation of mass. So the number of atoms going into a reaction has to equal what's coming out. And so we're just going to jump right back in where we're going to model this on paper to make it, this is what a chemical reaction would look like. This is the recipe. And so we're going to go ahead and count up what we've got here. This is, I'm looking at this side, the reactant side there, and I see we've got a sodium atom, Na. We've got oxygen there. We've got hydrogen. And we've got S, which is for sulfur. I know Na is one thing because it's a little a. And so whatever I've got on the reactant side, I'm going to have on the product side too. So I like doing them in the same order just because it's a little bit easier to look at. All right, and so I'm going to go ahead and count them up. Actually, tell you what, why don't you hit pause and you count them up. See how far you can take this problem on your own. Go ahead, do it, hit pause, and then if you want some help, come back. So here we go. Pause, and then now we're coming back, just like that. Okay, so 1 sodium. Did you hit pause? Then we've got 1 oxygen here. We got to recognize that there's 4 more here, and these are separate things because of that plus sign. So I'm going to go ahead and go 5. 1 there and 4 there. I've got 1 hydrogen there, 2 there, 3, and 1 S. Over here I've got 2 NAs, 5 oxygens, you see them? 2 hydrogens, and 1 sulfur. And so we're not balanced. And so I'm just going to look, I just work left to right. The first thing that I see that's not balanced is sodium. I got 2 here. So I'm going to go ahead and put a 2 in front over here, saying that I need to have that whole molecule twice. So if I do that, I'm going to recount. I now have 2 sodiums. Now I have 2 oxygens there, plus those 4 over there. So I've got a total of 6 oxygens. And I had 2 hydrogens there, and now I've got 2 hydrogens there, which is a total of 4 hydrogens here. 2 sodiums, but now oxygen's not balanced, and neither is hydrogen. And so I've got oxygen here, so I could put a number here to like change the number of oxygens, but I'm going to just kind of take a step back, and I'm going to recognize if I put a number there, I'm going to change all of that. There's got to be an easier way. And so I look over here, and the 2 things that I'm missing are a hydrogen and oxygen. So if I've got 4 oxygens there, that means to make a total of 6, I need 2 here, 4 plus 2. And so if I put a 2 there, that gives me 4 hydrogens there, which is what I'm looking for. And it gives me my 2 oxygens plus that 4 is 6. You see where I got those numbers? So there's, backing up, there's 2 sodiums, there's 4 oxygens there, plus the 2 oxygens there. 1 times 2, so that's a total of 6, plus 4 hydrogens and 1 sulfur. And I got that feeling again, it's balanced. Alright, moving forward. Why don't you go ahead and write this equation down, and then hit pause, then pause it, count it up, see if you can balance it on your own, and then come back in 3 seconds. And now we're back. Okay, so we're going to just do the same thing. I got nitrogen, I got hydrogen, I've got oxygen, nitrogen, hydrogen, oxygen. I'm going to count them up. 1, 3, 2. Over here I got 2, 2, 1. Not balanced. We just got to play with the recipe a little bit. That's why we're having so much fun. It's just like a little puzzle. And so I got 2 nitrogens there, 1 there. So I'm going to go ahead and put a 2 here. I always got to change up here before I count, right? That gives me 2 there. Now I've got 6 hydrogens. I'll come over here. I got 2. I'm going to go ahead and put my 3 in there to get 6 hydrogens. And now I've got 3 oxygens. And oh, bummers. I'm in that spot again. So do you remember what we do? If you've got an odd number here and an even number here, there's no number we can put right here to multiply by 2 to get an odd number. That means we got to back up a little bit. And the trick to get out of this jam is, again, you just double what you got. So we got to make this go away. And so I'm going to hit my eraser here. So we don't need 3, we want to double that. And so instead of 3, let's go 6. So now we've got 6 oxygens there, 12 hydrogens. Okay, so now I'm going to work this side again. We know that that number doesn't work there anymore. So I'm going to erase it. So if I need 6 hydrogens over here, that means I need this molecule. If each one's got 3, I need it 2 times. 2 times 3 is, excuse me, that's what we had before. We're going to have to do it more than that. We need it 12 times, and so that means I'm going to need it 4 times here, because 4 times 3 is 12. And now I've also changed my nitrogens, right, by putting that 4 in there. So I got 4 nitrogens. 4 times 1 is 4. You come back over here. I got 4 nitrogens here, so I'm going to have to put 2 there to get 4 there. Almost home free. I got 6 oxygens there, so what number goes here? Tell me. Yep, you're right. It's 3. Balanced. Notice 4 nitrogens in, 4 out, 12 hydrogens in, 12 out, 6 in, 6 out. Okay, we're going to do one more equation, and then we're going to call this thing a wrap. If you can do this one, you're good to go for the moment. Just breathe. This is our favorite equation because we're doing it right now. That's the crazy thing. While we're going to balance this equation, we're actually going to do this reaction in our bodies trillions of times. So I'm going to just go ahead and count them up. Oops. C, H, O. That's all on the reactant side, so I must have the same thing over here, and I do. I'm going to count them up. 6, 12, 6 there, plus 2 there is a total of 8. Over here I got 1, 2, 3. Easy as 1, 2, 3. Alright, so I'm going to probably make a mistake here. That's okay. We just got to play with the numbers. I got 6 carbons going in. I'm going to go ahead and put a 6 here to get 6 carbons there. 6 times 2 is 12 oxygens, plus 1 more right there. See it? It's 12. So it's going to be a total of 13. I don't like that odd number. Here's 2 hydrogens. So I got 12 hydrogens here. Let's see if that goes away. To get 12 hydrogens on this side, I'm going to put a 6 there. 6 times 2 is 12. And oh look, I think this is going to work out. So I've got my 12 oxygens there, plus 6 more oxygens here. That's a total of 18. And so sometimes the odd number disappears on its own, which is always nice. So carbon and hydrogen are good to go. So this is just a little tricky. I need a total of 18 oxygens on this side. I've got to recognize that I've got 6 right there, right? And so 6 plus 12 is 18. And so if I needed 12 right here, I'm going to multiply that by 6. So I've got 12 oxygens there plus those 6 equals 18. And bam, balanced again. How about that? And so we balance that cellular respiration while we're actually doing it in our bodies. Very cool. We're going to do one more part to this series, but if you're hanging with the first 6 equations we've done so far, basically you've got it. We'll make it just a little bit more tricky. But thanks for hanging with me. Feel free to go back and check out those again, and let me know if you have questions in class. All right, thanks.